Welcome everyone to today's Revolutionizing Healthcare session. We're diving into another fascinating topic, digital twins. It's going to be an engaging session again with some incredible minds joining us on the panel today. Here is how things will go. We'll kick off with a brief introduction of the session and our panelists, followed by our main speaker, Professor Mihaela van der Schaar is director of the Cambridge Center for AI and Medicine and professor at Cambridge. She will set the stage by explaining what digital twins are and why they matter in healthcare. Following that, we'll have a panel Q&A where we'll ask some key questions to get their perspectives on where the field is headed. And then, of course, as always, we want to hear from you as well. At the end, we'll open up the floor for your questions, so be sure to post them in the chat throughout this session. I think this is a great chance to get insights straight from the experts who are pioneering this space, so take full advantage. And with that, I'll hand over to Tim Schubert, who is an MD PhD student at Heidelberg University and an affiliate researcher at the Van der Schaar Lab. He will be co-hosting this session alongside me.
Thank you, Tim, and it's my great pleasure to introduce today's panel. First up, we have with us today Professor Radek Bukovsky, who is the Director of Computational Health and Medicine Initiatives at the Texas Advanced Computing Center and Associate Chair for Investigation and Discovery at the Department of Women's Health at the Oden Institute at the University of Texas at Austin. Next, we're really lucky to be joined by Dr. Phyllis Vangaraj, who's a cardiology fellow in the ABIM Physician Scientist Training Program at the Yale School of Medicine. Next up is one of the recurring faces on Revolutionizing Healthcare. We're really lucky to have Professor Ern McKinney with us today, who's a university lecturer in renal medicine at the University of Cambridge and also an honorary consultant in nephrology and transplantation. And he's also a faculty member at the Cambridge Center for AI in Medicine. Just as our next guest, also a recurring figure on Revolutionizing Healthcare, really lucky to have Dr. Alexander Gimson back, who's also faculty at the Cambridge Center for AI in Medicine. And with that, I will hand over to Mihaela to get started with this session by introducing the concept of digital twins.
So, good afternoon, everyone, and thank you so much for joining us. I'm terribly excited about today's session because it's a new technology and I think a very empowering technology. So with that, I wanted to have a very brief introduction to what digital twins are from my perspective. Why should we care in healthcare? And what does machine learning have to do with it? Next. So digital twins are dynamic virtual representations of a system. And the system could be a physical system of an individual, a patient, for instance, but that could also be a biological entity. It could be an organ, it could be a tumor, it could be a collection of organs. But we could also have digital twins at a higher level. We could have healthcare systems being digitally twinned, or why not a clinical trial? Next. And while today we are going to talk about medicine and healthcare, and this is the area that I am terribly excited about, the reality is that digital twins can make an impact in other domains such as education, finance, organization, cities, etc. So what are we really envisioning here? And how are these digital twins being built? They use real-time data, as well as whatever other observational data we may have, as well as knowledge, whether it is mechanistic, physiological, or pharmacological, as well as machine learning, to simulate how the real world would behave. And why do I really care so much about this area? We have worked over the years quite a lot in terms of building analytics, whether for prediction or for causality, to try to estimate the effect of a treatment on an individual. And the reality is that whether it's a predictive model, a risk scoring model, or a causal effect model, we want to really make the clinicians confident that whatever we are doing does indeed make sense. And for that, what we really need is not only analytics, but we need to have what I'm going to call wind tunnels. And you see here indeed the wind tunnel that is stress testing a particular component of a plane. In a similar way, we need ways to really envision what would happen to an individual if indeed we would act in a particular way, or if we would unroll subsequent scenarios. So this, if you like, wind tunnel is a digital twin, and I believe that it can help us understand better a particular individual or ecosystem, test hypotheses, but also timely and correctly intervene. Next. So in medicine, this could have impact in terms of personalized medicine, testing predictive analytics, and also enabling early diagnosis, a topic that's very dear to our heart, but also enable operational efficiency as well as provide insights for accelerated innovation. Next. So quantifiable benefits from this could be, for instance, and here are just a few, and I'm very keen to explore together with the panel many, many more, improved patient outcomes. Because, for instance, we can identify and predict early, and not only predict, I shouldn't use the word predict, we can really unravel what will happen to a particular individual or patient population and determine early that they are at risk for a particular morbidity or mortality, and we can intervene. But also in terms of cost saving, because we can really think about what the right interventions to do in a clinic or in a hospital to maximize, for instance, patient benefit. And last but not least, digital twins could be also very useful for enhanced accessibility, providing a broader reach of medical expertise via a variety of virtual platforms. Next. So what do we have in terms of core components? Very importantly, data and diverse sources of data, and data that's both observational in nature, but also real-time data. In terms of machine learning, generative models, combined with knowledge we may have, either physiological or pharmacological, and feedback loops, where as we gather more data about the physical system, we can update continuously the digital twin. Next. So how can machine learning help? We are talking here not about predictive models like we usually do in our Revolutionizing Healthcare, where we talk about risk prediction models or time series forecasting model or causal effect inference models. Here we talk about generation and generating these possible futures of this individual. So generative models are key, and also we need to do generation and validation as well. We know that as we move maybe further into the future, or if we want to create digital twins of less often present in the data individuals or scenarios that are less often represented, we also need to validate those as well as provide uncertainty quantification associated with this generation. Next. So at this stage, one may wonder whether a topic that we have often talked about in Revolutionizing Healthcare, synthetic data, is what digital twins are all about. Next. But the answer is no. There are some similarities with synthetic data, but there are also some key differences. Similarities are the fact that we want to simulate and represent real-world data, and privacy is a key consideration in both cases. And also, in different ways, synthetic data and digital twins can be used for decision support and decision making. But there are differences. While synthetic data focuses on really characterizing and generating population level data sets that are really synthesized through the process of synthetic data, in digital twins, we are focusing on synthesizing the individual. Also, while in synthetic data, we focus on static and generated once data sets, in the digital twins, we are continuously gathering new information and updating the twin. In terms of interventions, synthetic data is just capturing whatever interventions may exist in the data, but in the digital twin, they are becoming essential because what we want to do is scenario planning and consider the effect of all sorts of interventions that may not necessarily be existing for this particular individual, and hence we need to unroll these future scenarios. Next. So what about causality, which is another area that may seem similar since we are talking about using digital twins to think about interventions? Well, while both of them are useful for supporting interventions and do outcome prediction given a variety of interventions, as well as providing us with insights under different types of dynamics and scenarios, there are also key differences. Next. And these key differences are, again, causality focuses on estimating causal effect from observational data, while digital twins are very much about real-time simulation at the personalized level. Also, in terms of data, again, we have this difference that causality works on observational data sets, while digital twins may be trained on both observational and real-time data. Next. So the two, though, are also complementary because causal knowledge can empower digital twins. And conversely, next, testing causal hypothesis is hard, and digital twins may provide a virtual environment for us to do so. If you want to hear more about technology in machine learning that is unraveling as we speak in terms of digital twins, I invite you to watch an Inspiration Exchange, which is our sister session that is aimed at machine learners, where we have looked just yesterday about the technology of digital twins and what are the challenges in machine learning and some progress. Next. And I'd like to say a few words about some very recent work in our own lab, not because it's the only technology, there are others, but just to give you an idea about what is possible. And this is work on hybrid digital twins. Yeah, it's good. Together with two PhD students in my lab, Sam Holt and Tennyson Liu. And what we do in this digital twin, we do look at both mechanistic models for building digital twins that are based and grounded on biological or physical principles, and combine them with neural ways of building digital twins. And both these two technologies have been used for building digital twins, but the reality is that both have their strengths and weaknesses. So this is why we decided to marry the two of them. Next. So we built hybrid digital twins that are hybridizing mechanistic and neural models together. And what we are trying to do in this work is automatically determine the parametrization of these different digital twins and optimize them given the available data at hand. Next. So in our work, this hybrid digital twin, we use large language models to enable us to do that. And we have a novel evolutionary approach to do that. And this is done in 3 steps, utilizing the large language model as a generative model to iteratively propose digital twin specification, then offline optimize the parameters from training data, and then the model performance is automatically evaluated, fed back to the LLM, and we are continuously improving that. So this process is repeated over multiple generations until we are satisfied with the outcome. Next. You see here just a brief snapshot of the work. I'm not going to go into the details, but you see how this large language model has different types of components for model generation, parameter optimization, evaluation, and then reflection on the basis of which leads to new generation. Next. So this is my last slide. I'm very excited about digital twins because I think that they have the potential to really empower a variety of areas in medicine and healthcare. And I can't wait to talk to the four panelists about that. I have many questions to them, many things I do not understand, and also I can't envision, and I hope that they will lead us. I also am excited from a machine learning point of view because I think that this is emerging technology in machine learning. And again, depending on the requirements and needs, I think a lot of new ML is necessary. Thank you.
Let us get started with the panel.
Well, then maybe I start and the two teams can jump in. So, Phyllis, I'm so delighted to have you with us because I know that you have already worked quite a lot on this technology. So I want to start with you and ask, why are you excited about digital twins? Where do you think the opportunities lay? And where do you think the challenges are?
Thank you so much for having me. I'm really honored to be here. Yes, in cardiology especially, I'm excited about digital twins because they're pretty well established in specific aspects of cardiology, specifically for simulating procedural plannings to make sure that we have safe procedures being done on patients before we actually simulate them, specifically when people have arrhythmias. Also in trying to predict who's going to have a life-threatening arrhythmia. Generally, these really focus on mechanistic models versus, and they incorporate some statistical aspects like using variational autoencoders for building the simulations or CNNs for taking in the data segmentations for MRIs and things like that. But we see, and I think as you've so wonderfully summarized, a potential for building digital twins across patient populations. So looking at trials and trying to better understand and extrapolate how these trials translate to the general population. Specifically, our lab was looking in at using generative adversarial networks to take particular patient population and building a twin there of these patients and conditioning on a different randomized clinical trials with the same intervention, but a slightly different patient population to see basically how the effects translate to this other patient population. And so that's one aspect. I know what you've mentioned also in terms of simulating clinical trials, looking at people are considering particular building digital twins as controls. So randomized clinical trials themselves are very expensive and costly. And so could you use digital twins of controls to reduce the recruitment effort? And so those are two big opportunities. And also bring in, as you had mentioned, large language models. We use data such as ECGs, MRIs, CT scans, but certain things are untapped, like unstructured notes. And large language models can build that particular aspect up when we're trying to build the most complete digital twin model we can.
Amazing, Phyllis. Thank you. What about your thoughts on this topic?
Thanks, Mihaela. Firstly, very cool topic. I mean, we're basically talking about a fundamental overhaul of the evidence basis for medicine, right? I mean, it's nothing smaller than that. This is about as big as it gets in terms of potential. You know, we've had evidence-based medicine for a few decades. We've got randomized clinical trials, which are conceptually simplistic and straightforward, and you can extrapolate randomized trials into other system-level interventions, like, you know, should I change the way I have patient flux through my hospital? It's still an interventional approach to gain evidence for what you should do next. So to use observational data for that and to use twins as a method of approaching it is extremely exciting, I think, and partly because it allows you to potentially address questions that not just address the same questions, but in a better, cheaper, easier, faster way, but actually to address questions that we would never be able to address, that are not ethically possible to address. So trying to gain clinical evidence in populations that are never in clinical trials or that would be excluded on ethical grounds. So it sort of pushes back the boundaries of clinical evidence. So it's huge, or potentially huge, and I think therefore hugely exciting. For me, probably the biggest stumbling block I have is validation. So how do we know that they work? How do we know that the evidence that they generate is going to be good enough, and it has to be good enough to be acceptable to the community, to regulators, in order for it to be useful? And I think that's one of the most interesting areas, really. And it partly depends on a host of things. You know, when you say what is a twin, you might as well say what is a man, right? There's so many different ways in which you could define it and come up with it. And, you know, is it longitudinal? Is it cross-sectional? What data feeds into the generation of the twin? So we have to be very careful about defining it, very careful about identifying appropriately the context in which this can be useful. You know, do we have identifiability? Do we have a lack of...
You are touching on a lot of things that I plan to ask and brainstorm with all of you. So keep the idea. I'm going to turn the table on some of you and ask how to solve that. So sorry to interrupt, but
no, not at all.
You are stealing my questions.
I think validation is key. I mean, that's my bottom line.
I'll ask about that in just a little bit.
Perfect.
If you allow me, that's one of my next questions. Sorry for that. Radek, where do you see them used, and why are you excited about them, and what do you think are challenges, besides validation, to which we are going to return, I promise?
Well, thank you very much first for inviting me. This really sounds extremely exciting. And first, I want to say that I completely agree with everything that you just said. No, everybody who spoke before. And it's actually I was thinking, like, you know, should I just repeat everything that you just said before, you know, and say, you know, that how excited I am and how I agree with it. But I was also thinking about something else, how I started on it, and why did it all, how I found it, you know, that was important. And, you know, this is just my perspective. You might find it useful or not. But I think that this is, you know, to me, digital twin is basically the ultimate form of individualization. And I think this was something that we were always struggling. And to be honest, I think it's kind of a little bit of a secret, you know, of evidence-based medicine and everything that we use today for decision-making, that we actually are not using individualization. It is all based on averages. Then in reality don't exist. You know, there is nobody who is average. You know, you can have average on one thing, but not on 3 or 5. And it started you know, with, I think this is what underlies problems that we have with, in research, with reproducibility of medical research. I think, you know, some people call it a crisis. We can argue about the extent of it, but there is definitely that we have difficulties in reproducing things. And of course, with all the consequences of that, and that it's across all the disciplines. Second part, I think it's, you know, quite a struggle in clinical practice as well, for the same reason. So when we start looking into this, when I started looking into this, you know, we started with randomized controlled trials and started looking at just pure things like a number of characteristics that are assumed, you know, in those trials to be evenly distributed between the groups. And when you start looking at those number of those characteristics, for example, we had this one trial in obstetrics that was very impactful, you know, for 20 years dominated, you know, essentially what we were doing. And it was stopped early because it was considered to be unethical to continue with placebo in this trial. And the end result was, when I look at this trial, I said it was 447 patients ended up early, and 446 of them had individual combination of the 6 characteristics that that they reported as evenly distributed. We look in another study observational of 37,000 patients. 95% of those patients had an individual combination of 8 characteristics that we looked at. And then we had a population studies that we did, like models predicting, you know, some optimal modes of delivery for, you know, for obstetrics. And out of 4 million women who delivered in 1 year in the United States, 3.8 million specifically, 60%, 59% of them has a unique combination of 11 characteristics that they. So, you know, when one looks at this, you know, from this point of view, you know, it is pretty clear that this is a big problem, because those combinations are the ones that determine if treatment is effective, or in whom it is effective and in whom is not effective. And the same thing for diagnosis, you know. So I think this is, you know, this is at the same time bad news and a good news, because this is the way I see it, at least, it's that this is the perfect place to for digital twins, for individualization. On clinical
so
side,
much.
yeah,
sorry.
yeah, I don't know if I want to continue, but on the clinical side, just shortly, if one looks at effectiveness of treatments, for example, with this number needed to treat, just reciprocity of absolute risk reduction. Those numbers, when one really looks at it, even of the most used medications, and there was a study a few years ago, and they basically showed, what was the effectiveness or number needed to treat for the top 10 medications in the United States. Top 10 meaning top 10 grossing. Everything is about money here. So it was between 1 in 4 to 1 in 25 patients had to take it for several years in order for one to benefit. So, effectiveness is
Radek,
absolutely.
sorry to stop you. I know you are enthusiastic.
Yeah,
I want to go to many more questions. Apologies for interrupting. Sorry for that. So, Alex, I made your life difficult because I let you be last. So you will need to find some new ways to say why you are enthusiastic about this and why it's challenging. And then we can move to some new questions. I have so many questions for all of you, and it seems that the audience also. So.
Okay, well, look, I think like many of the other speakers, I do find this a really exciting topic, and I think as Owen said, I mean, this is the ultimate goal, really, of personalized medicine in its purest form. The things that interest me most of all is the way in which digital twins, which are able to be built up both from models of cellular processes to models of organ processes to models of physiological systems to models of pathophysiological systems, and then individualized at the same time. So I think that's going to give us unprecedented information. My questions, and I think some of them I can see are being raised in the chat, which give me real concern. I mean, the two I would say most important are how you are going to be able to evaluate whether one digital twin is more efficacious, better, more closer to ground truth than another one. I think that's quite an interesting and difficult topic. And the second one is, I think this is to do with causality, but it's to do with the degree to which there is, in fact, chance or randomness in medical outcomes. Are they all absolutely predictable? And these are something that we've always wanted to try to identify, and maybe using digital twins will be a way in which we can start to examine that question. So I'll leave it at that and pick things up as they come on in the chat.
Thank you very much. Maybe before we move to discuss validation, which clearly is the elephant in the room, maybe we can start by discussing just briefly what type of data we should use. And maybe I ask you, Phyllis, and you, Alex, to say something about what type of data you think we can use for these digital twins. And then I'm going to throw the more complex question of validation back at Owen in a little bit.
Sure. I think exactly what Alex just mentioned, thinking about what level of digital twin you're interested in depends on what data you're using. So in the cardiovascular sphere, we look at images. So it also depends on the individual. If you're looking at an individual cardiac heart, if you have the person's electrical signals, their imaging data for their heart, you can make a pretty good model of the heart and build these simulations to build a fairly good mechanistic digital twin. But when you go into looking at the individual at the cohort level or at the general patient level, you run into some issues, as people have alluded to, in terms of the missingness, not at random, of health data. But I think one thing that has come into play also are portables or wearables. So if you're trying to build real-time data streams of patients and building a digital twin of themselves, you now have access, if they're willing, to their environment, to their current health processes in terms of detecting abnormal heart rhythms, their oxygen levels. So you do have if you build this cohort, it's a pretty insular cohort. It's not something that's just going to drop in your drop in your lap. You can build a fairly good representation of a patient, I think, with what's available.
Maybe I ask any of the three of you, Alex, Radek, and to kind of complement what Phyllis said. So one challenge that I can think of, and I'm curious how you think about it, is depending on the purpose of this digital twin, depending on what do I build it for, how to select out of a vast amount of data the relevant data to build this twin. Any thoughts on that? And because I need to make decisions about what I'm going to model, what I'm not going to model, because I assume I'm not going to model really everything, no matter how rich the data is. So there are choices that need to be made. And I'd be keen if any of the three of you has any thoughts on that.
Can I make one comment? And I think Phyllis just touched on that. That's the degree to which, in some digital twin models, they're looking at a fixed point in time. And in most of healthcare, we are looking at time-dependent data, which so that there is evolution of the data over time, and indeed the way in which that data evolves over time does impact significantly an outcome that may be taken at time 0 as opposed to one that is taken at time 2 or 3 or further down the line. So I think how the digital twin will, if that isn't the wrong way of putting it, will have to age as well.
Definitely we need to age, and it should age in all the possible ways that the individual may potentially age. I think
that does seem to, but that does seem to me to become, the data then becomes exponentially more larger and longer to include that, rather than just doing it at a single point in time. Whether that will be technically possible to make these models age, I think will be very difficult.
I could quickly say, Mihaela, as well, I completely agree with Alex. We've also got to bear in mind what we're comparing them to, which is very static, very clunky, randomized trial evidence, where the trial that was done 10 years ago is still the trial that you base your clinical action on. So it may not be feasible that we, for example, and I see someone's put in the chat, right? You're running your ventilator in intensive care and you want to model against all the intensive care data that you've collected and see if I generate a twin based on everyone who is like my current patient, what will happen if I tweak up the ventilator settings, increase the inspiratory pressure, whatever. That may not be possible to actually generate real twin evidence, because validating that's even harder. But generating a piece of evidence analogous to a clinical trial, where I can query a data set and say, for this specific data set, what would happen if I did X, and then use that result and extrapolate it out. That's perhaps a lower bar in terms of validation, and is an intermediate step that's more akin to our use of clinical trial evidence at the moment. That's sort of to broach the idea of validation, because to answer your question about validation, how do we know this is good enough? I don't see a way around running twin studies concurrently with interventional studies to see if you get comparable results, right? And that's possible at group level. Obviously, if you come down to individual treatment effects for individual twins, that's harder, because you can never know the counterfactual, but you can know the group level of response from accumulated twins. So if we can compare an intervention to a twin's predicted intervention and get comparability, and you can do that with historical trials on existing data, for example, and I know you've done this, Mihaela, and at least in some contexts, that can reassure us that you can get comparable evidence. But I think for a specific context or a number of contexts, it's going to be necessary to do that to get enough confidence in the output of the result that we can use that clinical trial evidence. That's both enough confidence for clinicians and for regulators. Obviously,
maybe uncertainty and maybe uncertainty estimates associated with it.
On
such that we know when this twin may not be so related.
Well, exactly. A quantifiable measure of twinness, right? Are they identical twins? Or are they fraternal twins? You know, how twinny are they? You need to be able to quantify that to have confidence in the comparability of the result. But ultimately, it comes down to what the predicted outcome of a given intervention is, and whether that holds up when you go and do the intervention. And I don't see a way around linking the two together to get additional confidence in the approach. Obviously, twins have got so much more potential. And if we can show that bit and get that confidence, then we can go off and test the contexts where we'll never be able to do interventions.
Like a lot that you say, well, we need to be careful what we compare it with, because it's technology that needs to be compared against what we have today. And maybe the bar is...
And that's why we have to be very careful about how we do this, because we could show...
And for what purpose, I guess. Radek, any comments, especially on the validation side? And when do you think these twins would be useful indeed?
Again, I think I feel like I just would like to repeat everything that everybody said before, because they're the same issues. I think we all are in front of us. I think it's that actually this is a good sign, because it means that these are real problems. Everybody sees the same thing, or similar things. I think that first the data issue. I think that we have basically two things, two possibilities, and which are pretty obvious. One is the reanalysis, or using the data that we currently have and individualizing them, and the second is the new streams of data. And we have created here, for example, the infrastructure a few years ago for collecting and monitoring data from patients using the cell phone data that they're being automatically collected, and that means all the sensors as well as the usage, so telephone, texting, and other things. And so this is obviously something that could be very useful, because if you're talking about individualization, it's almost like one of gets pretty close to very individual things. You can superimpose GPS location on the maps of pollutions and other things that we have done. So that's the second part of the data. From validation point of view, it is obviously very complicated and difficult, but there is maybe kind of a sequential approach. I had here with our group, many times I repeated the same thing. We don't have to do it optimally. We just need to do it better than it is today. And today is the average. An average of the effect in a particular group in a study. It's an average in multiple studies. So we only need to improve. Validation is essentially in the fact that we can do something better than is currently done. So better than ever.
Amazing.
So maybe that's the kind of I know it's a little pedestrian, but it's kind of a first step maybe in approaching it. And you would be useful clinically.
Let me turn the gear and ask one more question, but from a different angle. So all of you talk about digital twins of patients, and clearly this is a very exciting area. And some of you even mentioned clinical trials and maybe synthetic control arms, and thank you for that. But what about digital twins of healthcare systems, whether of clinics or of hospitals? Any thoughts on that side? And again, how is that different? How do you envision that is different, whether it is on the data side, or are we talking on one hand about an easier problem because we are intervening on an entity rather than on an individual, or is it quite the opposite? It is more complex because we cannot disrupt the flow of an entire hospital or clinic. I don't know what the considerations would be from your point of view, and I'd like to learn from you.
I'll jump in really quickly. I think it would be a great place to start. Trials will be easier. Interventions will be easier. They'll be less risky. Outcomes will be shorter. It's conceptually slightly different. Well, it's slightly different to modeling patients and individuals as twins. But again, easier in the sense that there's a more trodden path in developing twins in manufacturing systems, from the first twins and then from NASA, right? So actually, it's more akin to the context where twin models are better established. So I think there's probably much more scope, and then if we can get more confidence in how robust they are, how we can use them, we could then move into patients. That's probably a better place to start, I would say. I
think in terms of healthcare systems, there kind of already is this quality improvement development cycle in place. This is maybe arguably a larger intervention to be done, but if it's actually built as a model of the health system, they are, in terms of, for example, EHR alerts, all these things are developed in a cyclical process and put into the system and taken out if they don't necessarily work. But there is precedent for this type of application in the healthcare system.
Thank you. Well, in view of time, and because we have so many questions, and I think my two co-hosts are asking, have questions of their own. Tim Schubert, I give the baton to you.
Thank you. So we'll just get started with the Q&A questions from the chat in just a minute. One question that we also wanted to ask is, maybe, yeah, whoever feels they can answer it. How do you expect clinicians to actually interact with digital twins in reality in the future if they become a thing? Is this going to be integrated somehow into electronic health records when you make decisions, or how would you expect that to be happening? Maybe I'll ask Ern first.
Sorry, Tim, could you repeat the question?
Yes, sure. So basically the question is, the concept is great, but in reality, how would you see a clinician of the future interacting with a digital twin? Is this going to be, yeah.
I think there's two possibilities broadly. One, as I say, is that we use twins to generate clinical evidence in areas where we can't, or to do it faster from real world observational data. And there are existing manifestations that are a bit like this with emulation trials from real world observational data. So that's one context. The second context is where you would actually be using data to generate a twin in real time. So real time of flight, where I have a patient and I want to generate the twin to answer the question that I've got now. I think that's harder because it'll be a lot harder to validate. So I would expect that the former context would be the one that we can broach first of all, and perhaps at system level before we can do it with individuals.
If I may, I think so, exactly like what you just said. I think it's in stages probably. It's going to happen. The easier first. But ultimately, I think that what we all want is, to have for all of us to have a digital twin somewhere in a computer. We come to, a patient or a doctor, we can say, that's what has happened to you today. And then we can explore your counterfactuals, for the next action that we are going to do at the stage of where you are at the moment with aging and, with the things that happen to you. Yeah, I think that's how I would see it, ultimately.
So Radek, you are saying that it is the patient in the end that will also benefit, not only the clinician.
Well, let's hope so.
You are well, excuse me. Yeah, no, you are right. I mean, you view this as the patients themselves having their own digital avatar on their phone or on their computer and being able to consult it, or they would issue alerts for us. That's what you were saying?
Perhaps, but most importantly, that we will have our digital twin of of Radek and Mihaela. That this is my version, and I can explore then what could happen. If I do this treatment versus I don't do it, or do I need to?
But it will help us get better interventions, such as better eating, sleep, and exercise. They may convince us.
More individual, for sure. It's a little bit akin to what they do, or they are trying to do in aerospace. When they have, each plane has their own digital twin, and then they model so many landings, and this kind of weather and other things, and how soon you should make exchange in the parts and things like this, something like that. And that might be all crazy, but I think it sounds like could be useful for everybody. By the way, I wanted to add about the system that, if I may, just quickly, I think is going to be much more difficult than doing it with the individual, because system, like healthcare system, is system of systems. So the things are getting quite complicated. But I think, I spoke with you, Mihaela, about that this is probably a good place for system dynamics this model, this kind of models, to deploy. Sorry,
I also wanted to just say, once we have evidence, I would say, especially maybe in interventions, I could imagine randomized control trials where you have physician-guided digital twins versus standard of care. Once the evidence is out there that maybe it's better, then you need the infrastructure investment from the hospital to train physicians on how to use the digital twins and how you would interact with them in terms of how, I mean, like we use now treatments, this is also kind of an intervention that could be used, but needs investment from infrastructure.
Okay.
Thank you.
Thank you, everyone. And I think that also brings us to the Q&A segment for the participants as well, who have been very active in the chat. So we have some questions to go through. Let's start off with the first question from Sanjay. Please feel free to unmute yourself and address the panelist you want to ask your question to.
Sorry, thank you. I guess one of the big questions is causality. How, and we've kind of touched on this, but causality versus association is such a big thing. And how do you unravel this conundrum?
And who would you like to address?
That's a general question, I think.
Well, I'll jump, and I'm sure Owen, who loves causality, will add something to it as well. So one type of thought that we can have is that if causal mechanisms are known or discovered on the basis of observational data, we can make sure, as I was alluding to in my presentation, we can make sure that the digital twins do respect these causal mechanisms. So if such information is indeed known about diseases, about relationships between diseases, about the time at which interactions between different diseases occur, and the causality, if you like, between these different factors is known, then the digital twins, when they are generated, can be generated in such a way that such rules, such mechanisms are respected. If you look at our recent work in this area, this is very much the case. That's the reason we have a hybrid twin, which has both mechanistic component that could have a causal component into it, and then there is a neural component that is trying really to deal with all the complexity and the diversity of the data. So that's one thing.
And just to challenge you on that, you can fully understand that from a reductionist approach, that makes complete sense. When one looks at the hybrid, how is that going to embrace a complex, heterogeneous system where you have so many variables? And coming back to, I can see its utility in an N of 1, but how does that help us when we're guiding policy or when we're thinking about broader therapeutic intervention?
So that's the reason this process of hybridization, which allow us to integrate very diverse sources of information from the individual history of that patient for which we are building the twin. So the richness of the data, the longitudinality of the data, but also the multimodality of the data could be nicely incorporated as part of the generation process through the hybridization model and the neural component of it. This is where machine learning has made quite a lot of advances in the last, with foundational models and many other models. So there is quite some hope that we can do that. Of course, the question, and causal mechanisms could be driving this generative process. Of course, the question remains, what's the best way to validate? But in view of time, maybe, I don't know, we can either have somebody else say something or we can move to the next question. Tim.
Yeah, I think unless someone wants to urgently add something, let us move on because we have many questions to go through. Next up would be Ingeborg Weltes. Would you like to unmute yourself and ask your question as well? And feel free to come on video.
Hello. So obviously, as a clinician, I wonder how you will start developing these twins. So my concept was, but I might be wrong here, that you will use existing data as a starting point. But then these existing data may have limitations with regards to the population they comprise or the geographical area where they have been collected. Would you still use them and then sort of refine in each iteration of the twin, or how would this work in practice? And then moving over to the more clinical side of things, obviously clinicians are a suspicious branch of people, and they are very slow to adopt what is called evidence-based. How will you convince them that a digital twin, which is something most clinicians probably won't understand, that they can potentially make better decisions than an experienced clinician? So how will you convince them to implement the twin into their daily practice?
So I
Thank
take
you.
that one quickly.
Yeah, or maybe we can, also ask Phyllis, but you can
first
start
component,
on.
I completely agree, you're only as good as the data you're built on, but just remember, so is your clinical trial. Clinical trials are based on a tiny fraction that is utterly unrepresentative of the population that we treat. So we have the potential to use real-world observational data to make that representation much, much better than it currently is. So yeah, you're absolutely right. It's only as good as the data it's based on, only as good as the population you extract it from, but it could be better than clinical trials. For the second point, how do you convince people? Well, if I told you that you can, if you were to generate or try and take observational data from a population of people who are matched to a randomized clinical trial and estimate using a digital twin approach the treatment effect for each of the individuals in that group, and then summarize across all those individuals, you would expect to get a result that was comparable to the clinical trial that was done, right? That validation approach is similar to an emulation study. So emulation studies have shown that this is possible on real-world clinical trial data. Mihaela's group have done this, for example, for the heart protection study with some of the digital twin approaches before, and shown that you can get comparable results to a clinical trial. So that's as far as we've got so far. That's not quite the same as actually doing the same thing in parallel. So predicting an individual response using a twin model and doing the intervention at the same time and comparing the outcome results. That's pushing that slightly further. And I wonder if that second context might be necessary to really convince clinicians that it can work.
Yeah, I guess I can only just add that, that maybe a little bit of experience that I had myself here. So one thing we have done is, we on basically how to identify the twins, we looked basically on characteristic for responders to treatment in the trials, and people who did not respond, as well as then people who were harmed. And then that essentially was kind of a very basic way to approach it. And I think it's quite understandable and palatable. The one thing that about convincing physicians, I know that we are very suspicious. I'm one of those people myself, and probably for a good reason. There was some, some history behind it. But one thing that really is a little thing that works quite convincingly, I think, is those things called number needed to treat or number needed to predict. When one looks at things like this, like statins that we, for example, people use all the time, and then you look that you have to that 260 people have to take them for a year to prevent one coronary heart disease. Then puts things in perspective, meaning that 265 of them took it for a year and nothing happened. So I think that's kind of maybe a way to at least to bring it and make it more palatable to physicians.
Thank
I also
you.
just wanted to touch on the getting over the geographical variation across different patient populations. Right now, with there's a lot of artificial intelligence models for detecting disease using EKGs, echoes, and one aspect that is done is called federated learning, which is where you have external validation across different hospital systems, across different systems where you just send the model out and you don't have to share data. You just do an external validation in your healthcare system itself. And I could envision doing something like that with the digital twin model itself, figuring out how in your patient population it'll work.
Thank you. I think it makes sense for us to move on to Mark's question. And I think this will be a good question for Phyllis as well, given your physics background. So Mark, if you would want to unmute yourself and ask your question.
Sorry, can you hear me?
Yes.
I work in ICU. I've used a couple of systems that seem to be a little bit like digital twins. So ICM Plus measures the pressure in people's brains after a brain injury, looks at how that pressure changes as the blood pressure changes, and then can recommend an optimal blood pressure. Similarly, IntelliVent looks at kind of lung compliance at different pressures within that patient and then tries to recommend an optimal kind of ventilation strategy. I'm conscious that at some point our bodies become so complex and we don't fully understand it, it starts to be a bit like an n-body problem in physics. And I'd be interested from the panel where you think that kind of boundary between what is tractable and what is science fiction might lie.
So at least from what I've seen in current mechanistic digital twin models of the heart, maybe not of the lungs, maybe the heart is a little bit more simplistic than the alveoli and compliance that you would see in tweaking ventilator settings, but we have the models available to measure blood flow, detect tissue stress. I would imagine specifically in a ventilator setting, being able to, I guess, sorry, my answer to your question is really focusing on the box, like the lungs and the system around it, that rather than trying to think of every single permutation of that patient's current state, because there's only so much you can control, especially even in the ventilator. But if you are able to put in what you know and the specific mechanics of the organs you're most interested in, I think that is a good start for trying to build a good digital twin of this particular problem.
I'd say that there's a conceptual difference between using an individual's data as a feedback system to see how they respond or have responded historically. In that context, the twin is the same individual, what they've done before. You don't know that the current context is the same as how they would have responded yesterday. They may have gone into fluid overload. They may have developed an infection. Doesn't mean what happens now is predicted by what happened before. The concept of a twin is that you would use all other patients or the most similar contributor patients who have been in that situation before in your database, repository, ICU unit, whatever, to create an average twin that is most similar to your patient and predict it that way. So I think there's a conceptual difference from what you're describing, those tools and twin models.
Okay, thank you. In the interest of time, I suggest we take one more question and I'll address it to you, Alexander. Maybe I'll just let Vivi Kandan ask it live as well. Please unmute yourself. Or I can ask it as well. When it comes to precision medicine, how far does the personal data protection and confidentiality should be preserved in digital twins? Do you consider applying GDPR when developing them?
Yep. So I think that's a great question, and the simple answer to it is that at the moment there are the whole of the regulatory process for data is trying to catch up with the speed with which we generate new synthetic data or digital twins, and so I think we're quite a long way from answering that question at the moment. So GDPR clearly does not apply to the use of a digital twin model when you have it in place, because the GDPR relates to an individual. The digital twin, in that sense, in the legal sense, is not an individual. But because we're using them to be a replica, a model of the real person, then I think as we get them, as they become better and better, as we've discussed, there are lots of different ways in which we can try to make them better, but as they become better and better, more realistic representations of the individual, then you're right, we will have to reconsider the whole issue of the degree to which it's such a close model, then it will infringe privacy laws. But at the moment, those are not relevant as we're developing at the moment.
Okay, thank you. Again, in the interest of time, I would maybe ask each panelist to give one or two sentences, not longer than that, their future view on digital twins and what they have gathered from this session. And then we can wrap up. I'll maybe let Professor McKinney start, if that's okay.
Thanks. My expectation is there'll be really exciting development work in terms of methodology, but there's a fundamental need for the community to get together and define what acceptable validation would be, so that we've got something to shoot for.
Thank you. Professor Bukowski?
I think the same. I think it's going to be something that's definitely going to happen. You know, I don't think we have any other choice, to be honest. I think there are, of course, ethical issues there of importance, although every time I go through security in the airport or get my face scanned and my eyes, you know, I always wonder about that aspect as well, you know, how much we have already given up of that. And finally, I think that the way I see it is that this is going to be all incremental, meaning, you know, we only, as I said, need to do better than today. We don't have to do it perfectly.
Okay, thank you. Very nice. Phyllis, I will give it to you as well.
Yeah, so agree, especially validation will be very important, building randomized clinical trials of these digital twins compared to intervention. And also, I do think the future does hold considering building trial level digital twins. And you can do this at the individual level. I mean, there's individuals within the trial, but putting it at scale and really thinking of the entire trial as a whole, as we've discussed, randomized clinical trials are really only a small aspect of the general population. So I think that's a really important direction to go into.
So can I suggest, I mean, I think it's a common theme that we're discussing here today, that everyone's discussing, which is the crucial importance of evaluation. And I think until we have got some really robust ways which the medical community understand and feel confidence in as to how we validate digital twins, I think they will have difficulty in progressing. One way which we have touched upon is to use digital twins to try to see if you can replicate past randomized trials. I think Phyllis was speaking to that. I think that's one way of going back into history and saying, if I made a digital twin of all the data in this particular trial and then follow through, what would the outcome have been different? Would it have predicted a different outcome? Would it have predicted a more realistic outcome? Because as Owen has said, outcomes from trials are not necessarily as realistic as they can be when translated into a wider community. So how we replicate and how we evaluate twins, I still think will be the biggest issue to be addressed in the future.
Thank you. It's also food for thought for future sessions on our sessions as well. Before we wrap up, I'd like to thank the panelists for joining us, and I would also want to discuss our next session on the 3rd of December. We'll be discussing the progress we made in AI education for clinicians. Phyllis already alluded to the fact that we are gonna have to start training the clinicians to start using AI to actually reap the benefits. So I think this is a really relevant session for everybody who is a fan of this topic. And we'd love for you to be a part of this conversation. And we also encourage you to invite your colleagues as well. They can sign up through our page. And the session will also be able to be found online on YouTube tomorrow. So thank to our panelists again. Thank to you, our participants, for all your good questions. And we look forward to seeing you next session.